Discuss the curve y equals cosine squared of x minus 2 sine of x, where x is from 0 to 2 pi, with respect to concavity, points of inflection, and local maxima and minima. So again, we have y equals cosine squared of x minus 2 sine of x. The domain of this function is actually all real numbers, but we are restricting the domain just for this problem. We're going to restrict x be from 0 to 2 pi. So to find the local maxima and minima, we're going to need the first derivative. So differentiating with respect to x, notice that we're going to have to use the chain rule here. The derivative of cosine squared of x. Well, the outside function is the square function, so we have 2 times cosine of x times negative sine of x. And then the derivative of sine is cosine, so we have minus 2 times cosine of x. What we'll do is what we've done in previous problems, we're going to factor. So the first derivative can be written as negative 2 cosine of x. I'm factoring out negative 2 times cosine of x. And what I'm left with is sine of x plus 1. And again, keep in mind that I'm on the interval 0 to 2 pi. So cosine of x is equal to 0 at x is equal to pi over 2. And sine of x is equal to negative 1 at 3 pi over 2. So at these two values, pi over 2 and 3 pi over 2, the first derivative is actually equal to 0. So what we want to do is draw a sine chart. Okay, so you're going to have to remember the unit circle. Okay, so if x is between 0 and pi over 2, both sine and cosine are positive, but I have a negative 2 out here. So between 0 and pi over 2, the function is actually decreasing because the derivative is negative. Now between pi over 2 and 3 pi over 2, keep in mind these are the only two x values where the function could actually change sign. So what you can do is plug in a test point, plug in something between pi over 2 and 3 pi over 2, and I think pi will work. Sine of pi is 0, cosine of pi is negative 1, but I have a negative 2 here. So between pi over 2 and 3 pi over 2, the first derivative is actually positive. So what that tells us is that at x is equal to pi over 2, we're going to have a local minimum. And between 3 pi over 2 and 2 pi, again, what you can do is use a test point. So use a test point. So the test point should be in the 4th quadrant. And in the 4th quadrant, sine is negative, but it's still greater than -1. So sine of x plus 1 is still going to be positive. Cosine is positive in the in the 4th quadrant. So this quantity is positive, that quantity is positive, but I still have a -2. So what that tells us is that we have a local minimum at x is equal to pi over 2 and a local maximum at x is equal to 3 pi over 2. So let's go back to our original equation. I want the corresponding y values. Well, at pi over 2, cosine is 0, okay? And sine is equal to 1. So what's going to happen at pi over 2 is y is going to be -2. So that's actually the local minimum value. It occurs at x is equal to pi over 2, but the function value is -2. Now at 3 pi over 2, again, cosine of 3 pi over 2 is 0, so cosine squared of 3 pi over 2 is also 0. Sine of 3 pi over 2 is -1. -2 times -1 is a +2. So our local maximum value is y is equal to 2. This problem will be continued on the next video.